Thanks for waking up so early after the big party last night. Okay, so I'm going to present modular anonymous networking, what it is, why it's important for the future of modular blockchains, including Celestia, and the general concept is that we can add noise to data to make it unlinkable, and so even very powerful adversaries are easily defeated. So what most people don't think about, you can think about your execution level, you can think about your data availability level, and these are all great, but the Achilles heel of every single blockchain project is actually this often very 90s peer-to-peer protocol, which no one really bothers to look at. And having that protocol work properly is just taken for granted. But actually, in reality, it's very easy to monitor and attack these protocols. Machine learning in particular makes it trivial to look at your traffic, establish a unique fingerprint for what you're doing, either if that's web browsing or data sampling, identify your node, and then basically either block that node, like a denial of service attack, or make that node believe something that's not true. And that's quite dangerous. And luckily, there is a solution. Even though the internet was not really built with security or privacy in mind, with TCP/IP and UDP, we can add what's called an anonymous networking layer, sort of a modular, better networking layer to the existing network. So we built something called a mixnet. What a mixnet does is it adds noise. It's like a noise-generating network to obfuscate patterns in the network traffic. It does this similar to a VPN or Tor by adding multiple hops to the traffic, but also, quite importantly, adds application-specific noise, which you can think of as like fake traffic or dummy traffic, which scrambles the peer-to-peer or other network patterns. And then timing obfuscation. What that means, because it's a mixnet, is that the traffic at each hop, we'll illustrate this in a second, is mixed together with other traffic. And just like you can use different execution layers and different consensus algorithms, you can take mixnets and you can tune them to your apps. Let's say I don't really care about being anonymous, but I want to hide my IP address. I can scale that mixing down, and I can make it much faster. If I really want to be anonymous, I can take a hit on latency and add more mixing. If I have a lot of bandwidth, I can add more noise. If I have less bandwidth, I can add less noise. But the general lesson is, no matter what you want to do, the existing peer-to-peer networks are a bunch of shit, and you can actually add in something like a mixnet to strengthen your network, including your peer-to-peer network, including, importantly, making that traffic unlinkable. So that means that if I send out traffic, I'm, let's say, checking data availability sampling, the particular peer or light node client, which is doing that data availability sampling, cannot be linked by an adversary back to its network traffic. So you can basically link, check, be unlinkable, and check data availability anonymously. The same holds for email. If you were going to use an email with a mixnet, I want to send an anonymous email out. That's what the original cypherpunk use case was. You can't link that email back to the sender. And even an adversary as powerful as the NSA with all their AI technology who's watching the entire internet with a kind of godlike view, couldn't effectively do that linking back. So this is what it looks like. You have your kind of standard VPN down here, which is shoveling traffic back and forth. And you'll notice that the packets have like different sizes and times. Like you don't send all the packets out uniformly when you use internet. Internet traffic is bursty. And in that way, your traffic unfortunately kind of leads you to have a unique fingerprint. That's used to identify you and link your traffic to your computer, which website you're going to, even if you're encrypting the data using TLS, so forth and so on. Same with Tor. So Tor is obviously better because it's not centralized, although the directory authority is. But Tor kind of works like a 3-hop VPN. But you can see the packets still have that same pattern And that's quite dangerous in terms of trying to make your traffic anonymous, or as I prefer to say, unlinkable. What you can see what NIM does, which is a bit different, is the traffic comes out your computer with that pattern, but then it's shipped through layers of what we call mixed nodes. And those mixed nodes, we add this kind of noise into the traffic, and the mixed nodes delay the particular packets. So you can see all the packets come out the same size and looking the same. And that's quite cool. And this works today. So we're going to talk about data availability and noise generating mixed nets. So if you're on the Celestia research forum, you can read this nice little thing by Dimitris Karakostas, I think, a research post on what's called a selective disclosure attack. So the selective disclosure attack is quite dangerous. I'm running a Celestia Lite client. I'm randomly sampling the network, the data, via the network. I'm randomly sampling the network using these erasure codes. But someone could be watching the network or watching my computer, and they can basically cause me, even if I'm honest, to either believe an unavailable block is available, or a block which is available is unavailable. And you do this simply by monitoring the IP address and censoring or altering the network flows. And you can see that it's really easy to do. This attack has a pretty high probability of succeeding if there's like not many queries. And the more queries you do, you assume that you can get by the attacker. So it's a pretty dangerous attack, and it really effectively destroys a lot of the value proposition of data availability sampling, which is obviously a cool technique. We want to keep using data availability sampling. And so Mustafa, who I've known for many years, has another cool blog post on Celestia Research called Security Levels of Data Availability. So I'll just summarize it briefly. Mustafa has much more detail in his blog post, but effectively says there's different levels of data availability sampling. And if I'm just like copying the data from a full node or just sampling myself, it's actually completely insecure because the statistical disclosure attack can basically make me lie even if I'm honest. So it's sort of pointless to even do the data availability sampling. So he said the simplest thing you can do is you basically have to have a committee, and that committee kind of gets consensus on data availability. But the problem is, how do you prevent the committee from lying? So you need slashing or some kind of cryptoeconomic security with the committee. He considers that level 2. But slashing with a data availability committee doesn't work too well because of this thing Mustafa calls the fisherman's dilemma. So what he recommends that you have to do basically, rather than a data availability committee, this is what most people assume now, we do kind of an honest minority of light nodes. But if you don't have that group of light nodes, and what you need is an unlinkable data availability sampling. And unlinkable data availability sampling, how do we do that? So the unlinkable data availability sampling says that all these techniques can be attacked, so we really need to make that sampling unlinkable so an adversary can't like zoom in on my light client and either knock it offline, give it fake traffic, give it a fake view of the network, and we need to make that traffic unlinkable, and that's why we need what we just described, a motherfucking mixed net. So here, this is kind of how data availability sampling works. So I have all my light nodes, you have Alice and Bob, and they're going through this peer-to-peer network, which everyone kind of forgets exists, and they're sampling the block, and they're continuing to do that. And what you can do is you can put a mixed net in between the light clients and the peer-to-peer network. We already do that with Monero, we do that with Bitcoin, we do that with libp2p and Ethereum validators, and there's no reason the mixed net can do that with Celestia. We haven't done the integration yet, but it should be fairly straightforward. And effectively, you just put the mixed net again between the light node and the blocks, and that makes particular light client sampling unlinkable. And what's like the property you want, a bit more formally, given a query for the same recently disseminated block, an adversarial server cannot tell which user it belongs to amongst a set of users who were recently made aware of that block. And this is from another blog post, Evaluation of Private Networks for Bypassing Selective Disclosure Attacks and Data Availability Sampling. And while I like Dimitri's first post, this post is completely wrong because essentially Dimitri's just read a bunch of papers and didn't look at any running code. So he's kind of like confused how the papers work. So he's like, well, maybe we could use Tor, maybe we could use this thing that doesn't work, maybe we could use an imaginary thing. And that's fine for researchers, because researchers can read papers and not actually look at code. But, as I'd like to point out, the NIM mixnet works today. It's solid Rust code. It's been running for like 3 years, used by quite a few people. We can use it today upstairs if you're interested. So we would recommend that rather than wait for something that doesn't exist to exist, or use a technique like Tor or VPN where you don't actually get that unlinkability, you would just use NIM there. And so you might be like, what is this NIM, and how can I use it today? So if you're interested in trying out a mixnet, Sarenko, raise your hand. This man will be upstairs on the second floor, and he will let you install and try out a mixnet. You basically get a free super VPN just for waking up and having your coffee and showing up at this ungodly hour. So what the NIM VPN is just the mixnet, but with a nice little interface on top of it. And it gives you the best privacy by generating noise to defeat, and it's a decentralized network, so you can run nodes and get NIM tokens. We're not going to talk about that here, but essentially you make noise in a decentralized fashion together, and that makes everyone more secure and more anonymous. And effectively, it works across all major platforms, all major mobile apps, whatever. You can just download it in TestFlight or F-Droid, and it's obviously more private than Tor, and has about 700 nodes, so you have a lot of places you can pop in and out. It's a real-world network. It's been running for a few years now, and looks more or less like this. So when you start up your phone and you want to use a mixnet because you want to really be anonymous, I don't want to know what exactly you're doing. Don't tell me. But if you have a reason to be anonymous, that could be something as innocent and completely legal as data sampling. You just click mixnet, and you're super anonymous. And if you're like, oh, I want to download some videos, I want to be faster, like I said, you can turn the mixing off, and you can just click fast mode, 2-hop. And then you can choose, oh, I want my node to come in Sweden, because I like the Pirate Bay or whatever, and I want to come out in France, because, I don't know, I want to fool the French government into thinking I'm coming in France. Most people probably go to the US for Netflix or something. But you can basically choose exactly where you come in and out, and you just hit the connect button. Now, it's not available to the general public right now because we're still beta testing it. We're still trying to get the network is solid, but there may be some flaws. It may be a little bit hard to install. With iOS, you got to like install it, turn off, turn on again. It's irritating. Some other minor issues, but most importantly, of course, because it's an anonymous networking tool, we don't want you to log in with like your name or your username or password. So you have to log in with a zero-knowledge proof. And those are not public right now, but again, talk to Sarenko over there, and he will, up on the second floor, and he will hand you your own custom one-time zero-knowledge proof that you can use to log in. And the zero-knowledge proof shows that you're not a spammer, because obviously if you have an anonymous network, you can get a lot of anonymous spam. And then delinks your kind of identity, which is given via zero-knowledge proof, from your usage of the network. You can download it now, but it won't work until you install that zero-knowledge proof, but feel free to give it a shot. And just talk to us. I'll be here afterwards, and we'll be happy to install it on your phone. I'll probably have to leave around lunch, but Sarenko here will be here all day. And again, I want to just end with a note that this is really like mixnets. Noise-generating mixnets are a really useful way to make any traffic secure and anonymous. If you read academic papers, it's called an anonymous channel. For many years, people have just assumed that they exist. You assume it exists with data availability sampling. Zcash, you read the Zcash paper, says, oh yeah, just assume it's all running over a mixnet. But they haven't existed. So we spent many years building one, and you can use it for not just a VPN, you can use it for data sampling. It works on WebSockets. You can install it on web pages. If you're living in China or whatever, it might be useful for accessing the internet. All sorts of stuff is going on with it. So I do recommend, if you're interested, just talk to us. We're happy to show you the full plan. But just so you know, we were testing it mostly in Ukraine, Turkey, Germany, so forth and so on. We launched the beta chaos of the VPN app at Chaos Computer Congress last year, which is an awesome place. I used to party with Mustafa at back in the day. And then we have launched the alpha testing, so it's not public. But if we don't build on Polkadot, we do coordinate the mixnet using a blockchain. We use Cosmos, and we're interested in continuing to make it more modular. But we are going to launch at the Web3 Summit the kind of paid usage, so you can download the VPN, pay for it using TIA tokens or whatever, and that's awesome. And then you can basically, that TIA token or credit card just lets you use the network for as much as you want and converts and pays the decentralized nodes using NIM token, which just kind of does a little conversion between. And then we're going to kind of launch the whole thing, including a lot of focus on making it more censorship resistant against the Great Firewall later this year. So you've got a few months to just play around with it, and we'd love your feedback because we know we have a bunch of awesome hardcore hackers today. So again, VPN information here, general information about the mixnet here. That's our Twitter, and we're also, all the code is free software. It's on GitHub, and just contact us.